Let us look at question 84 again. Largest rectangle in histogram. In that question, you will be given an integer array. Each value in this array represents a bar high. The bar's width is 1. Then they ask you to return the maximum rectangle in all the histogram. So, for example, this first bar, the height is 2. So himself, the area size is 2 because 2 high, y is 1. If 2 bar 1 and bar 2 combine together, the rectangle will be here because 2 will cut to 1 to build the rectangle. So the size for the 2 bar, the rectangle still is 2. Okay, let us looking the 5 and 6. For that one, rectangle will be the 2, 5, so it's 10. So the example 1 will return 10 because we cannot find other rectangle is area size is more than 10. Okay, so let's go back the solution 1. In the solution 1, we have a lot of bar here. So our solution is find the shortest bar. We scan the whole array and find the shortest bar. What it means for the shortest bar? For the shortest bar, the area the shortest bar can build will be the shortest bar times the whole array length. For example, this is the shortest bar and this is the shortest bar. So this shortest bar can build the area will be the shortest bar's height times the whole array length. After do that one, we can split the whole array by the several pieces by this shortest bar. So here and here. So let us think about in that one. This one is between 2 short bars. So the maximum of the rectangle between these 2 short bars can no more than 2 short bars times the whole line. So they only can build the rectangle if they do not want to include the shortest. If you want to include the shortest, you have to downgrade the whole bar length to the shortest. So we can calculate between 2 shortest bars, find the maximum. We can use the same policy. Now we need to find in this area what is the maximum. So we can find the shortest in this 3 bar and use the same policy to find. So finally, the time complexity will be the big O of n log n. This is the time complexity for this algorithm. Find the shortest, and then by the shortest, we cut the whole array by several pieces. Between this piece, we find the shortest, then continue recursive, do the same thing. Then we find a solution. That is solution 1. Okay, let us to see, can we find the faster way to handle it? Yes, we can do it. The policy is you have the summer bar, right? The method is you create a stack. In the stack, you only save the bar in this ascent way. So how to do it is first we add this bar into the stack. This one we add to in this one. Then we go to the next bar. Okay, we add the next bar because the next one is higher than the first one. Then we find, oh, we have a lower one. Okay, we stop at it because we always want to add in this stack is from the short to high because we find some short one. So we need to remove our bar is higher than it. So bar 1 and bar 2 and bar 1 will be removed. When we do the remove, we can calculate the bar 1 and bar 2 can build the rectangle. The reason is, let us look this one. Bar 2 area will be bar 2's high. Bar 1's area they will build from bar 1 to bar 2 and time 2. The reason is we cannot go through to bar 3 because the bar 3 is less than them. If you want to include bar 3, you have to downgrade to the bar 3. So this area is dependent on bar 3. So if we meet some bar is less than it, we can stop calculate because we can calculate depending on this one. We do not need to depend on the bar higher than it. If that higher than it, we have to downgrade. So if we find some bar is high is shorter than the thing in the stack, we need to remove those things from the stack. So we calculate this one, and then remove them. So we remove it, okay, and only keep the bar 3. Okay, bar 3 and bar 4, we keep it. Then we find the bar 5. Bar 5 is shorter than bar 4. If we want to insert bar 5 into the stack, we have to remove this bar 4. So we calculate how is the bar 4 area and try to update the maximum. Okay, after we remove the bar 4, we check this bar 3. Hey, bar 3 is less than the bar 5, so we only remove the bar 4, but we keep the bar 5. Okay, so this is bar 5, bar 6, 7, 8, 9, 10. Okay, we have the bar 5. Then we insert bar 6. Okay, because bar 6 is higher than bar 5. In the stack, we only keep the higher one. Then we find the bar 7 is less than the bar 6. Okay, if we want to insert bar 7, we have to remove the bar 6. Okay, let us do little one for the bar 5. Okay, we find before we remove the bar 6, we need to calculate what is the bar 6 can have the lines. So bar 6 lines, include the bar 6 lines will be this one. Okay, we remove the bar 6. Then we find bar 5 is higher than bar 7. Okay, if bar 5 is higher than bar 7, we still need to remove the bar 5. But before remove it, we calculate bar 5 can build the area. Okay, what is bar 5 can build area? Bar 5 can build area will be this area. From previous one is bar 3 until the bar 7 in this area. So we know if we want to remove something from the stack, we calculate it can build the maximum area will from a stack previous value to the next value in that area. Okay, by this way, we continue insert bar 9 and bar 10. Okay, after we added the bar 10, we finish the first scan. Okay, in that scan, the time complexity is n. Then we have stack, right? For that stack, we have increased value. Then by this one, we can calculate if we include this bar, what is the maximum area? Okay, for the bar 10, what is this area? So bar 10's area will be end of the bar, his previous one, this area. So we calculate any bar can build the maximum area will be go to, for example, this bar 9. Bar 9's area will be the before the previous bar in the stack and until end. So this is bar 9's area. What is the bar 3's area? So bar 3 area is will be the from the beginning, because bar 3 is the shortest in the whole array, so it's until here. So the whole idea is scan one time and scan back the stack. Build first scan, build the stack. In the stack, everything will be increased, and then when we build the stack, we scan the stack from last one to the top, and also calculate in this bar in the stack can build the maximum array, maximum area. So finally, we can build the maximum. So this scan back also is time complexity is big O of n. So totally, the time complexity is big O of n. That is faster than the n log n. Okay, let us write the code to implement it. So we need to have the stack, right? So let us see the constraints. Okay, at least have one element in the array, and this is the array value. Okay, so first we use the list as the stack, and then what is the information we put in the stack? We need to put information his index and his line is high. So we use the int array to save those information. Actually, every time we have two array. If we want to build the more readable code, we can create the class to do it. Class info so it's index and high. Okay, so we also can use that one. It's more readable. Okay. First, we need to add some stop flag. So this is a stack. So stack add new info -1 and -1. So his index index from 0, so we add some stop one, right? We never need to handle it. And then we need to add the first one will be the 0 and is high. And then we have the for loop. T is we can use total is so here is I1 less than total. Okay. Okay. Then we need to compare with the previous one, right? So we have some previous one. Will be the height 0 because we already put the first one here. So okay, his height is from index, and if height is less than pre-value, so in here we find some drop. We need to remove the higher one from the stack. Less if this value is less than this high. Okay. So in that one, first we get a stack size. And okay, so we also need to do a while loop to remove everything from stack if it's higher than the current value. So we can add this one. So we need to get the first one, right? Stack get as size -1. Okay, so if for this is in for P1's high is less than current high, so we stop here. We break this loop. So because this one sometime will hit this stop flag, so at least they will break. If we reach the shortest in the array, but this one still is bigger than -1, so they will break. Otherwise, we need to get the previous one because we need this calculate stop point. Stack get size -2. Here, for example, 5 and 6. So when we calculate what is 5 can build the area. So 5 area should be from the indexed 1 to indexed 4. So we need to get the 1th index. Okay. So here we also need max is 0 and return max. So here we calculate the area. So area will be the I1. I1 is current location, right? Current location minus the you want to calculate the bar 5's value. So you need to get it before the bar 5's bars index. So from bar 4 minus bar 1, you get 3. You also need minus 1. And then you need to calculate 5, right? So you need to calculate 5's high. So this here, we calculate is 10. So if A is a big area, new area is more than max, max will be the A. And then we do stack remove size minus 1. So we find something, then we need to remove 6, remove 5. Okay, now in the stack we keep 1, 2. Okay, so for example, this one, after this loop, they will keep 1, 2, 3. Then after this for loop, we will do the exactly same thing for this one. So we copy this one, put here. Let us say here, go. Okay. So continue do the exactly thing from this one. We get a stack size and if stack, because right now we need to remove everything, right? Stack we get is 1. If here less than this one, here we need to use -1 to break, because when we pop up the first stop flag, we break. Otherwise, we continue get the previous one. And then here is not I1. Here should be the total. We from the end of the array location to get his previous location and -1. If the previous one is -1, what it means for that one? This location. So it still work because we set up the previous location is -1. It's before the 0, right? So still is work. Okay, let us try to run it. Output 2. What's wrong for that one? Let us debug it. This 10 should be updated from here. Oh, we forget one thing. After this done, we forget add new info into stack. So this one with I1 and high. So and also we have need a we get is a previous high, update this one to the current high. Okay, and let us submit it. Yeah. So by this way, it's much faster than the n log n times complexity algorithm. This is a big O of n time complexity. Space, they did not use too much space. I think this is space is still is we use stack, right? So the space complexity is a big O of M. Thank you for watching the video.